So she asked me, why do I have the screencast for those who are not here? Mm. And she said, like, it's a responsibility to be joining the class every day. And I get that. I mean, believe me, you know, um, I'm one of the teachers who don't give away grades and stuff like that. But let's just be mindful of the fact that some people are not as fortunate as we are. So they do have some limitations, and sometimes that affects their ability to join classes. Mm. Okay, so as your classmates have mentioned, we distribute 3 to the 3x minus 4 and become 9x minus 12. And then we do this again, 1 over 4, right? If you're trying to distribute a fraction, so pretty much you are going to divide 32 and 56 by 4, right? Okay, so let's do that. If we divide 32 by 4, you get at 8. Okay, so 8x plus 56 divided by 4 will become 14. There you go. Okay, so then we're going to collect like terms again. You have the 9x. We have to move the 8x over. So minus 8x equals, bring down the 14 because it was originally there. And then you add the 12. So you do its opposite. And then after that, 9x minus 8x, 8x is x. Now 14 plus 12 is 26. So writing down the reasons, this is given. And then this is distributive property, just like what some of you mentioned earlier. And then we collect the like terms together. No, not yet. We subtracted the 8 from both sides. So subtraction, property of equality. And last but not the least is we simplify. Okay, so take note that in all these examples, the equation has one solution, and the solution is given by x is equal to negative 2, right? Um, However, on the other side, we will see equations that do not necessarily have one solution. In fact, in one of your individual work today, chat 8x plus 14. Okay, is that on the next one, honey? Is that on the next example? Oh, okay. So you were giving this one 8x plus 14. Sorry, look, I didn't see it right away. Okay, so for this one, you have the given information again, right? Now let's see what's going to happen here. If you, it's okay, that's fine. If you distribute again 3 times 5, you will get 15x, right? 3 times 5x is 15x. Now 3 times 2 is positive 6, so plus 6 is equal to 15x. Okay. That's funny, look. Okay, don't worry. All right. So 15x plus 6 is equal to 15. Um, so now you're going to collect the like terms together. So we can subtract 15x from both sides. Okay. Um, and then we can move the 6 over. And where am I? So we can move the 6 over and change its sign to negative. But look what's going to happen. 15x minus 15x, that's a 0x. And we don't put 0x because 0 times anything will just be 0, is equal to negative 6. Now, is this true or false? So I'm pretty sure that we solved it correctly. We distributed, right? Distribute, distributive property. And then after that, we subtracted 15x from both sides. Subtraction property of equality. And then after that, we collected the like terms or simplify, but we came up with a false statement. So what does that mean? So if you come up with a false statement, this is a false statement because for them to be equal, they have to be exactly the same on both sides. So that means the equation has no solution. All right. So far we've seen an example of an equation that has no solution, and that's regardless of how these two are arranged. You can have negative 6 equal to 0, but the bottom line is if the left and the right hand sides do not match, then the equation has no solution. Okay, you can hear that blower again in my background. Um, I think I should follow my husband's advice of using a noise canceling headphone. I should buy one of those. Okay, so now what else could happen? Now let me see. Let's highlight some of what we wrote down here. Equations do not always have one solution. An equation that's true for all the values of the variable is an identity, and that's what I'm going to show you next, and has infinitely many solutions. Highlight that one as well. Uh, Infinitely many solutions. There you go. Okay, but an equation that is not true for any value has no solution, and that's what we just saw earlier. So this means that whatever we plug in for x, you won't be able to match the left hand side of the left hand side with the right hand side, which is pretty obvious because here you have 15x on both sides, right? And this one you're adding 6, but you're not adding anything over here on the right hand side. Okay, so let's do this. Again, we're going to distribute the -2 to the parentheses. So you get -8y, and then -2 times 1 will be -2 is equal to -8y minus 2. Now from here, you can actually stop right here. Okay, so let me put a note right here that says, oops. Okay, so you may arrive at a conclusion at this point. So when you're solving, you don't have to do anything past this. Okay, however, maybe like you weren't so sure and you're not that confident that, hey, did I do it the right way, etc. Then you can keep, you can keep solving and verify. So we can collect the like terms together. So -8y, but I have to move this other -8y over here. So plus 8y is equal to, you bring down this -2, which was there originally. And then the other -2 from the left-hand side will move to the right-hand side. You get plus 2. Ooh, what happens now? Well, -8y plus 8y, that's a 0, right? And then -2 plus 2, that's another 0. What happened? Well, regardless whether it's 0 equals 0 or 5 equals 5 or 8y minus 2 equals 8y minus 2, this is a true statement because the left hand side and the right hand side are matching. So at this point, you can conclude that the equation has oh has infinitely many solutions. All right. In other words, the equation is an identity. Is an identity. Okay. And we saw that in two parts of our solution. Here, the left and the right hand sides match, and then this one also. Okay, 0 is equal to 0. All right, so this part is actually the only, this is the only thing new in our series of 3 lessons on solving linear equations. Okay, so let's look at some example over here. We have the distance on water problem. Oh, I forgot to change the title of this one. Can you guys change this one? This should be biking problem. So just put biking. All right. So how are we going to use what we just learned to solve these two word problems? Okay. So go ahead and read the problem silently. Okay. So in the chat, after the first time you read it, Can you tell me what the problem is about? In the chat, can you tell me what the problem is about? Please don't give me just the title. So what is it about? What are we looking for? What do we want to know? So what is the problem on your left-hand side about? Please type your answers in the chat. Let me guess. Some of you are working on your makeup work already, huh? We're almost done. Our Zoom time is 9 to 9:40. Sometimes or most of the time I go over time. I know. Okay, so what is the problem about? It's about anybody? Somebody type in the chat. Anyone? What is the problem about? A boat leaves New Orleans and travels upstream, excuse me, on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster. Um, Faster downstream due to the current. Excuse me. How far does the boat travel upstream? Anyone? So what is the problem about? What are we looking for? What do we want to know? Anyone? What's the keyword? What are we looking for here? And what formula are we going to use? Distance. Okay, very good, Nyla. So how fast the boat travels? Very good. All right, the distance covered upstream, right? And since Nyla already mentioned about the distance, and Alyssa mentioned something about how fast, in other words, we call that the rate, right, Alyssa? So we're talking about distance, rate. So based on those keywords, can you tell me what's that formula that we have to use in this problem? So distance is equal to what? So distance is equal to rate. Alyssa's how fast the boat travels is actually the rate. Rate times what? What do we multiply it by? Remember your formula DRT. So what does T stand for? Distance is equal to rate times time. That's awesome, Nyla. Okay, and we know that the distance upstream is actually equal to the distance downstream, right? Because the boat traveled the same, what do you call this? The boat traveled definitely the same amount or the same distance. However, the rate for downstream is faster because if you're traveling with the current, um, then your boat goes faster, right? If you're traveling against the current, then the current slows the opposing current also slows down your movement. Okay, so the distance upstream is equal to the distance downstream. So in other words, um, for each one, we're going to put rate times time going upstream. That will also be equal to rate times time going downstream, right? So what basically are we doing? I wrote down the formula for distance here, but we know that the distance traveled going up or upstream is the same as the distance downstream. So by substitution, the distance upstream is just rate times time, and the distance downstream is also rate times time. So our problem now is um, what are we going to substitute for this one? By the way, just to define our variables as well, I'm just going to put D is equal to RT. D is equal to RT. Okay, so the rate times time going upstream. According to the first sentence, the boat travels for 4 hours, but it did not mention anything about the rate, right? Okay, so then we're going to call that X. So let X be the rate of the boat going upstream, and the time of the boat upstream is 4 hours. There you go. So X times 4. We can say X times 4 or R times 4, however you want it. Okay, it's the same one. Maybe I can include it here in defining our variable that x is equal to the rate, right? So if you are reading this on your own, at least you know where x came from. So x is equal to 4. And then what about downstream? So according to the problem, the return trip takes only 2.8 hours. So the time is now 2.8 because the boat travels 3 miles faster. So if it's 3 miles faster, then what are we going to do? What operation are we going to use to the current variable that we have x? So a rate here will be x, and then, but it's faster. So what am I going to do? Do I add 4? Do I minus 4 to the rate? If it says 3 miles per hour faster. So how do we translate that to a mathematical symbol? So if the boat traveled x miles per hour going upstream, so we have to add 4, or not 4, 3, right? Add plus according to Nyla. So we're going to add x plus 3. Oops. That's, okay. So x plus 3, that's the rate going upstream or downstream. So going with the current, but I need to put that in parentheses. Okay. There you go. And the time it took is 2.8 hours only. So 2.8. So if you're kind of like confused right now or lost, we just use the formula rate times time repeatedly, where rate is x because that's what we're looking for, right? Um, or that's one of the things that we need in order to find the distance traveled. So the rate of the boat going upstream is x. Going downstream, it became 3 miles faster, so we added 3. Nyla said change it to plus, so x plus 3. And then the time for upstream is 4 hours, while the time for downstream is 2.8 hours. Okay, so now let's simplify this. We have 4x is equal to, you got to distribute this guy, right? You can also move that here to the front if you want to. Oh, Bixby did not understand that. Sorry. My phone is. Yeah. And I know some of you are saying, oh, I did not understand that either. Okay. So, um, again, let's multiply this 4x and then we distribute this one. So 2.8x, right? Plus, and then you multiply 2.8 times 3. So that's going to be 8 times 3 is 24, carry 2, so 8.4. All right. Okay, are there any questions so far? Let me know. Let's pause there. Any questions? None? You guys sure? Okay, so now we're going to collect the like terms together. So 4x, we got to move that negative or that positive 2.8 and make it negative, and then leave the 8.4 over there. Okay, so we get 1.2x is equal to 8.4. Okay, so now let me increase this. Let me lower that instead. All right, so now we're going to divide 8.4 by 1.2. So x is equal to 7. But we don't stop there because according to Nyla, we're looking for the distance. And according to Alyssa, we're looking for how fast the boat travels. And this is how fast the boat travels. The boat travels. Okay, this is upstream, right? Okay, so we have already found Alyssa's response earlier. So x is equal to 7 is how fast the boat travels upstream. So now, how far Nyla's response earlier was distance. So how far does the boat travel upstream? And how are we going to do that? So the distance now, we're just going to substitute what we guys found here into our formula. Distance is equal to rate times time. So the boat traveled, the formula is D is equal to RT, right? The rate is 7, okay? Now the time going upstream is 4 hours. So rate times time. So the boat travels 7 times 4, which is equal to 28 miles, okay, upstream. Well, the 28 miles should be for both upstream and downstream, right? Um, you can also verify that for the downstream distance, um, the rate going downstream we said was x plus 3 because the boat traveled 3 miles faster. So the 7 will actually become a 10, okay? And the time downstream is shorter, it's 2.8. Okay. Now you can see that that's also equal to 28, right? Okay, although that's not what they're looking for, but I think it's worth mentioning that the way you can verify your work is the boat traveled the same amount of distance, either going upstream or downstream. Okay, what changed is the rate because it traveled faster going downstream. Okay, so let's type in here. What did we do first? So we set up an equation with variables on both sides to model the story or the situation or the scenario, however you want to call it. I normally call it story problem. So we set up an equation with variables on both sides, right? To model the story problem. And then we set the distance traveled upstream and downstream equal. Oh, what's wrong with my keyboard? And downstream equal and solve for the rate um, of the boat. All right, so that's one way of explaining your work. You can be more specific. You can also mention, some properties that you used, but at least you explain, your answer in context. So we would say the boat travels at a rate of 7 miles per hour. There you go. And the distance traveled is 28 miles. Okay, and that's one of the applications of solving equations. You will be you'll be seeing a similar problem, but now it's not about upstream and downstream, but the same concept applies to a biking problem. So when you bike from one point to another, you're covering the same amount of distance. So what changes sometimes is the rate when you travel slower, going one way and faster on the other. There's no internet, honey?
No.
Okay. Um, all right. Hang on, guys. Sorry. Okay, launch for Zoom meeting again over here. Okay. Struggles of a Zoom mom and a Zoom parent, right? Okay. So, do you have any questions so far? Now, as promised, um, I only went 4 minutes over time today. Okay, so what I would like you to do, guys, I'm going to stay online. I'm not going to go. But I need you to work on your grades. Okay, so if you have questions, then stay and ask me questions. If you don't have questions, um, and you don't have any missing work, you do have a lot of stuff that you can do in Schoology. I made all of them visible, so don't think that you have nothing to do. Okay. Is there any homework tonight? Honey, if your grade is good, you got no homework tonight. I haven't created a new Delta Math homework until I uploaded the grades. Okay. So you can do this. Go advance instead of doing homework. Okay? So we've done this. You have one three-read problem that you have to do on your own. You have some skills practice about today's work, some interleave review. So all of this plus some more that I will upload in the future will be graded this week. So if you don't have any homework, then go advanced. All right. Okay, are the instructions clear? So stay if you have questions. If your grade is A, then do these. You got nothing else to do but these four. If your grade is not A, then you need to do the makeup work and catch up on Delta Math homework if you haven't done so. All right.